What's good, math family? In today's video, I'm going to show you guys how to solve exponential equations by rewriting the common base and solving for the exponent. Starting this video off, everyone, we have to make sure that before we try to solve for these exponents, that we have the same base. That's the most important thing. And properties of exponents helps with this lesson. So what we want is to have the same base. So luckily for us, 27 and 81 share a common base of 3. I know that if I rewrite this as 3 to the third power and I keep that 3x on the outside, that is the same exact problem. I just rewrote it with a different base. And then when I go over to the other side, we're going to have 3 to the fourth power, which represents 81, just written with a different base. So now that we have the same base, we focus on the exponents. So I'm going to multiply 3 and 3x to get 9x, right? If there's nothing on the outside, we could just say 1, and we know 9x is equal to 4 times 1, which is 4. Then once we solve by dividing, I'm going to get x is equal to 4 over 9. So that's problem number 1. Problem number 2 is a little bit different because we could solve this in 2 different ways, or 2 different bases, I should say. So the first one is just to keep it as a base of 4. All right, so this stays the same. We have 4 to the 3x power, and this is equal to 4 to the, let's see, I want to say it's the third power too. Let me check my notes. Yeah, to the third power. So now once I drop the bases, I'm going to have 3x is equal to 3. I'm going to get x is equal to positive 1. Now let's say that at first you guys didn't see the base of 4 and you said, okay, I'm going to do a base of 2. That could work as well. So let's switch back over to blue and let's see what happens when we use a different base. Are we going to get the same answer? Is there more work? So we're going to go right here, right? So I know 4 is just 2 to the second power. 3x on the outside. And this is equal to, and then what is it again? I want to say it's 2 to the 6th power. Let's just grab the calculator. Let's make sure before I keep going. So 2 to the 6th power is 64. So we rewrite this as 2 to the 6th power. Now, once I drop my bases, right? 2 times 3x gives me 6x. All we have over here is 6 as an exponent. We get x is equal to positive 1 again. So even if we use a different base, we'll still get the same answer. Now up here, same exact thing, guys. We've already used 81. So we know that we could go down here and rewrite this as 3 to the fourth power. Oops, wrong marker. So when we go now, this side stays the same. So we're going to rewrite 81 as 3 to the fourth power. So now when I drop my bases, I have negative 2x plus 2 is equal to 4. Turns into a regular equation, right? We continue to solve. Negative 2x is equal to, let's see, 2. Because we subtract, we know x is equal to negative 1. Right. And in the last problem of the day, guys, I don't want the fraction to confuse you. All we did was it's just a negative exponent, right? We know that 5 to the negative 3 power is equal to 1 over 125. So that's all that's going on right here. So this base stays the same. 5 to the 3x is equal to, we rewrite this with a base of 5. 5 to the negative 3 power. I drop the base, pick up the exponents. I know that 3x is equal to negative 3. And I know as a result, x is equal to negative 1. So really hope this review on exponential equations with common bases was helpful for you guys. Please remember to review your exponent rules and and revisit how to rewrite exponents with common bases. It'll really help. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters. Smash the like button for us, subscribe to the channel, and leave comments for future videos you guys would like to see on our channel, or if you had questions from today's video.